still on chemistry. Before we go on, make sure to like, share, and subscribe. So today's topic is particulate nature of matter. Matter is made up of discrete particles, the main ones being atoms, molecules, and ions. So atoms are the smallest particle of an element that can take part in a chemical reaction. Atoms are the smallest particle of an element that can take part in a chemical reaction. Molecules are the smallest particle of a substance that can exist alone and still retain its chemical property, be it an element or a substance. Okay, so like I said earlier, matter is made up of discrete particles. The atoms, the molecules, and the ions. So I define atoms as the smallest particle of an element that can take part in a chemical reaction. Or you can decide to define atoms as the smallest part of an element that can exist and still retain the chemical property of that element. Okay, so you can define it as the smallest particle of an element that can exist and still retain the chemical property of that element. Molecules, on the other hand, is the smallest particle of a substance, the smallest particle of a substance that can exist alone and still retain the chemical property of that substance, be it an element or a compound. So it can either be an element or a compound. Ions, on the other hand, is any atom or group of atoms that possesses an electrical charge. Okay? Now, from what we've defined, you can conclude that atoms are the basic units for simple substances or elements. Okay, so I'm going to draw a three-dimensional structure of an atom. Okay, so the structure of an atom. Say we have something like this. Okay. Yes. So, from what we have on the board, we see that some are positively charged. This is the proton. This is the electron. This is the neutron. This is the orbit. Okay, so from the structure of the atom, we find out that the atom is made up of subparticles. These subparticles are three in number. We have the proton, the neutron, and the electron. Okay, the proton and the neutron, they are found in the nucleus. Okay, while the electron, they are found on the orbits. Now the proton is the positive charge of an element. It is represented, the proton is the positive charge of an element. It is represented as P+. The name of the scientist that discovered proton is Ernest Rutherford in the year 1911. So take note of the scientist that discovered proton and the year it was discovered, because it is normally a jam question. They could ask you, who was the scientist that discovered proton? His name is Ernest Rutherford. And in what year was proton discovered? It was discovered in 1911. This scientist discovered proton with the use of the gold foil experiment or the alpha particle experiment. Okay, so the next is the neutron. The neutron is the neutral charge of an element, meaning that it doesn't have a charge. It is represented with N superscript O. It was discovered by James Chadwick. And then we have electrons. Electrons are the negative charge of an element. The negative charge of an element. It was discovered by J.J. Thomson, and he used the discharge tube experiment, or we call it the cathode ray experiment. Okay, so that is that for the particulate nature of matter and the structures and the atomic subparticles. Now I'm going to go further to tell us about the atomic mass and the atomic number. So the atomic number of an element is equal to the number of protons. Mathematically, the atomic number equals the number of protons. Okay? So, notes, remember, the chemical property of any element depends on the atomic number, not the mass number, but the atomic number. Remember. Now we have the mass number also. The mass number equals the number of protons plus the number of neutrons. The mass number equals the number of protons plus the number of neutrons. Mathematically, it's represented as this: number of protons plus number of neutrons. An element is represented as A, as X, A, Z, where our A is mass number and our Z is atomic number. Okay? Now, our number of neutrons, like I said, if you make number of neutrons subject of the formula, you'll be getting mass number minus number of proton, and number of proton equals the atomic number. So to get the number of neutron in this, you can say number of neutron equals A minus Z. So mass number minus atomic number gives us the number of neutron. Also note that a neutral element, which is an element without an electrical charge, the number of neutron equals the number of electron. In a neutral element, the number of proton equals the number of electron. Okay? So remember. Now I'm going to give us a question so that we can understand properly what we're doing here. So say we have an element X 35.5, 17 here, and we have to find our mass number, atomic number, number of proton, number of electron, and number of neutron. Okay, so our mass number, like I said, our mass number is always written on top, on the left hand side of the element. So our mass number here is 35.5. Our atomic number is always written on this side, below, on the left hand side of the element, below. So our atomic number equals 17. Okay, our number of proton is equal to our atomic number, which is also 17. Now, our electron, for a neutral element, like I said, the number of protons equals the number of electrons. Now, if you look at this element properly, you find out there is no charge attached to it. So the number of proton equals the number of electrons, which is 17. Now, our neutron is the difference between the mass number and the atomic number, which is 35.5 minus 17. which is going to give us 18.5. Okay, now I'm going to take another example so that you guys can take like 1 minute to solve before I give us the answer. So say we have an element, sodium. Okay, now our mass number, which is on top on the left hand side, is 23. So the mass number is 23. Our atomic number is 11. Now our atomic number equals the number of protons. So the number of proton is 11. This is a neutral element, so the number of electron is also 11. Now the number of neutron is 23 minus 11, which is 12. Okay, now I'm going to go forward and teach us about ions. Now, from my definition earlier, ions is any atom or atoms that possess electrical charge. Ions are gotten when an element loses or gains an electron. Okay, so mathematically, when a neutral element loses an electron or gains an electron, you obtain an ion. Okay, there are two types of ions. So ions are of two types: the cations and the anions. The cations are gotten when an element loses an electron. So when there is a loss of electron, we obtain a cation, and it is represented as X plus, a positive sign. An anion is gotten when an element gains an electron, and it is represented as X minus. So if you look properly, you see that there is a reverse process here. When you lose, you obtain an X plus. When you gain, is represented as X minus. Examples of cation: we have sodium plus, aluminium 3 plus, magnesium 2 plus, etc. Now for anions, we have chlorine, oxygen 2 minus. Okay. Okay. Now note, remember, one, that metals undergo this process. They ionize by loss of electron to form cations, while non-metals ionize by this process, gain of electron to form anions. Okay, so metals undergo this process, non-metals undergo this process. Note also that cations are normally smaller or lesser than their parent element in terms of electron. They are normally smaller in terms of electron, while anions are bigger in terms of electron. Okay, so I'm going to give us an example so that we can understand this properly. So say we have an ion, aluminium 3 plus, 24 here and 13. Now we're asked to look for the mass number, the atomic number, the number of proton, the number of electron, and the number of neutron. From what we discussed earlier, our mass number is found on top on the left hand side. So here it is 24. Our atomic number is 13. Our atomic number is also equal to our proton number, which is 13. Now, if we look properly, this element is charged. It has a positive charge. And what did I say about elements with a positive charge? I say that they are cations. Cations are represented with a positive charge. And cations are formed when an element loses an electron. So this element has lost 3 electrons. So it's no longer going to be 13. It's going to be 13 minus 3, which is going to give us 10. Okay? Now, the number of neutrons is 24 minus 13, which is the mass number minus the number of neutrons, which is going to give us 11. Okay? So I'm going to give us a table to summarize everything I have done. So, okay. So this is elements. Let's say this is 12, 12. Okay, so now we have to fill in the gap. So here we're going to start with this. Here we have our mass number to be 24. Okay, our mass number is 24 and our neutron number is 12. And we know that our mass number is equal to the neutron minus our mass. Okay, we know that our mass number equals proton plus neutron. So to get proton, we're going to do 24 minus 12, which is going to give us a 12. Now, because this is a charged element, the proton is not equal to the electron, and because there is a plus here, this tells us that it's a cation. So what are we going to do? We're going to minus 2 from the number of protons to give us a 10. Okay? Now, the second question, we're giving our mass number to be 16 and our proton to be 8. So to get the number of neutrons, we're going to do mass number minus proton number, which is going to give us an 8. Now, this is also a charged element. So our proton number is not equal to the electron. So what are we going to do? Because this is an anion, and anions, they gain electrons. We're going to be adding 2 to our proton to give us 10. Now, the third question is a neutral element. So our electron equals our proton. I said it here. Neutral elements, the proton number equals the electron number. So since our electron here is 13, here will be 13. Now, our number of neutrons is gotten from 27 minus 13 is going to give us 14. Okay, now this is a neutral element. So our number of electrons equals our proton number. And our mass number is the sum of the neutron plus the proton number, which is going to give us 23. I hope you guys enjoyed this lesson. Thank you very much. Make sure to give me a thumbs up. Thank you. I remain your teacher, Emelda Ezugwu.